Yo, 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 this is Mr. O. Yo, 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 Mr. O. And today we're gonna learn how to graph quadratic equation, inequalities, and combine with piecewise function. And I'm gonna share you the shortcut, the technique that wherein we don't have to make a table of values in graphing quadratic equation. Okay, and also the transformation. When does it goes to left or right, up or down. All right. So right now we know that the parabola is the name of the graph of quadratic equation, which is like a U shape, or goes opens downward also, right? All right, and let's go ahead now. So another form of quadratic equation is called the vertex form. The word vertex, we can easily find the vertex here just by looking at the equation. The form is y is equal to ax minus h squared plus k, wherein your h and k are your vertex. K are your vertex. And the axis of symmetry is x is equal to h. And the a here is the one that determines the width and the direction of the parabola. Okay, so what's the meaning of this one here? So if I have y is equal to say 4x minus 2 squared plus 5, this is in a vertex form. You can see that y is isolated and there's a value of a outside, parenthesis x minus 2, which is your h, and squared plus 5. First, the vertex here is 2 comma 5. That's your h and that's your k. So if you notice, this is negative 2, but the vertex here is 2. That's 5, that's 5. So basically, you can say you flip the sign, but technically the formula there, or the form really has a minus. So whatever the h here is your x coordinate for the vertex. And whatever the value of k there, whether it's positive or negative, as is, that will be the coordinate for the y on your vertex. And whatever the x coordinate there, that will give you the axis of symmetry. And since that's 2, so the axis of symmetry or line of symmetry will be x is equal to 2. Okay, and the value of a here is 4. The a here is 4. It tells so many things. Number one, there's this called the compression and stretch, which I will tell you more. Like, you can say that the stretch and the compression are talking about how skinny is the U or how wide is the U. Okay, and also since a there is positive, it opens upward, and if it opens upward, we know the vertex there is the minimum value. So the a is really important on identifying the direction and the behavior of the graph. Okay, one more. If I have y is equal to, let's say, negative x plus 3 squared, let's say, that's it. So for this case here, the h here is 3, but it's positive here, and we know the formula is minus, so technically that is minus negative, so the h there value is negative 3, and there's no number here, that means it's plus 0, so therefore the vertex there is negative 3 comma 0. And the axis of symmetry, again, the axis of symmetry is the x value on your vertex, which is here is negative 3. So write x equal to negative 3, which is a line, a vertical line. The value of a here is negative 1. There's an invisible 1 right here. So we know it opens downward, and the width of that one is 1 unit, the scale factor of 1. And since it opens downward, so this is your maximum value or your vertex. Okay, something like that. Okay. All right, let's go to detail of the transformation of the quadratic function. So again, that's your vertex form. Y is equal to a times the quantity x minus h squared plus k. By the way, the squared is an indicator that it's quadratic. Okay, quadratic is the function that we're doing, and parabola is the name of the graph of quadratic. So the horizontal shifts. For the horizontal shift, we will focus on the h, and the k dictates the vertical shift. Okay, so let me give you an idea here. So the parent function first, the parent function of quadratic is y is equal to x squared. We know there that it starts at the origin. And here's a technique without doing a table values. It's called the 135 method. Okay. 135. What's the meaning of that one? From the vertex there, you go up one over. You go up three. One, two, three, over. One, two, three, four, five, over. If you notice, I just keep going up one, over, up three, over, up five, over. And that's how I get the points. If you do the table of values, you should get the same thing. Okay. And that's only the shortcut. And then if you have to do the other side, you'll just flip over the next side and just a reflection, and make sure you connect them with a U shape, not a V, arrowheads, kaboom. As simple as that one. That is the graph of y is equal to x squared. Now, what happened when we have a y equals x squared minus 4? What do you think will happen? Everything, all those points there will go down by 4, okay? All of them will go down by 4, all those red points, okay? So this is a vertical shift. So I'm gonna tell you that the 4 there, that means it's gonna go down by 4. So the vertex will start here on the negative 4. And you do the same thing, the 1, 3, 5, okay? So go up 1, over, up 3, 1, 2, 3, over, 1, 2, 3, 4, 5, over, and then reflection, reflection, reflection. And then I need you to look at the blue and the black graph. How will you describe the transformation? From the blue, from the parent function, it went down by 4 because of the minus 4 here, because your k becomes negative. Okay, that's how it works. And you know, if I have y is equal to x squared plus 2, what do you think will happen? From the parent function, it will go up by 2. 1, 2. So now let me use a different color there. I'm going to use a green. So from the origin, 1, 2, and then apply the 1, 3, 5 again. One up, one over, up 3, over. You can go with 5. I can just keep it 1, 1, 3 only. I don't have space anymore. And then reflection, reflection there. And just simply connect them. And you will see from the blue to green, it went up by 2 units because of the plus 2 here. And that's how the vertical shift moves. Okay. All right, let's move here. What about the horizontal shifting? You know, for horizontal shift, you focus on the x minus h. Okay, so if you're, you know, the parent function is y is equal to x squared, which is the same thing as y is equal to x minus 0 squared. That's why it starts at the origin. Okay, if you have y is equal to x plus 4 squared, that means you see a 4, an H. The vertex, the H4 is to the right, okay? The vertex here is negative 4 comma 0. So you, because there's a plus 0 right here, right? So you go left 4, boom. If you notice, again, let me repeat myself, it's a plus 4, but it goes to the negative 4, okay? So you're going to the left 4 and then apply the technique. What's the technique again? 1, 3, 5. It can go 1, 3, 5, 7, 9, you know, but 135 is good enough. You know, we can see the parabola from there. So go from the vertex up 1 over 1, up 3, 1, 2, 3 over 1. And then reflection on the other side, reflection on the other side, and make your U shape, kaboom. So if you notice, the graph shift to the left by 4 units because it's 4, it's positive 4 there. So what do you think will happen if the question is y is equal to x, say minus 3 squared? Okay, so this one will be going, the minus 3 telling you that the vertex will be 3 comma 0. So 1, 2, 3, and then move 1, 3, 5, 1 up, 1 over, up 3 over, reflection, reflection, and boom. So how will you describe the orange graph? It moves 3 units to the right. So the 135 and the vertex are a good technique to graph it easily. Okay. So what happened if we combine them? You know, y is equal to, let's say, x plus, say, 3 squared minus 2. Okay, so what's the vertex here? We know that the vertex here is negative 3, negative 2. So you start at the vertex all the time, negative 3 down 2, and then apply the 1, 3, 5, up 1, over, up 3, 1, 2, 3, over, reflection, reflection, and then boom, connect them. There you go. So from the parent function, which is in what's in the origin, it moves 3 to the left and went down 2 units. Okay. All right. One more. What if we include a negative? Negative x minus 4 squared minus 2. The vertex here is 4 comma negative 2. The a here is negative 1. Remember, there's a negative 1 here. That tells us it opens downward. Okay, so in that case, we're going to the right. I'm gonna use a red one. Let's use a black one. Right 4, let down 2. And then this time, since it opens downward, we're still gonna apply the 1, 3, 5, but we're gonna go down 1, over, down 3, over, and reflection, reflection on the other side, and connect them. Kaboom. And that's the graph of y equals negative x minus 4 squared minus 2. All right. Now, what if we have a compression or stretch? Okay. Here's how I look at it. When the value of a is bigger than 1, think of this one here. When the value of a is bigger than 1, you work harder. When you work harder, you go to the gym. That means you get a little skinnier. When you less you have a less time of going to the gym from 0 to 1 hour, you probably a little, get wider, that's how, just for me to remember things, for example, let's say y is equal to, let's say, let's go over this way, x squared first. That's the parent function. You go to the origin, 1 up, 1 over, up 3 over, reflection, reflection, and then we just connect them, right? We connect them, boom, boom. So that's a y equals x squared. Okay. So the value of a there is equal to 1. So what if we make it y equals to 3x squared? Okay. That's a there is equal to 3. Something bigger than the parent function. Okay. Here's how you graph it. Okay. Here's the technique. We know that we apply 1, 3, 5, right? If you have a value of a equals 3, you don't use 135. What you need to do, you multiply the 135 by 3 by 3. Where do you get the 3? From the a there. So this becomes 3, 9, 15. That means I'm going to start at the origin, the vertex to the origin. I'm going to go up 3. 1, 2, 3 over 1. Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, approximately over 1. There you go. Reflection, reflection. And I'm going to connect the purple points, make a U shape there, my parabola. How will you compare the blue and the purple? The graph becomes narrower or become compressed, vertically compressed. Okay, we call it vertically compressed. Okay, with the scale factor of 3, because the value of a is 3. All right, that's how you do that one. Oh, no, 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 not vertically compressed. My bad. Vertically stretch. They're stretch here because they are kind of tight. So vertically stretch. My bad. Vertically stretch. Okay. The graph from blue to purple, it becomes vertically stretch because of the value of a, which is bigger than 1. So if we reverse things here, if we do the compression, which is y is equal to, let's say, half of x squared, because 1/2 is smaller than 1 and 3 is the smallest one, we anticipated the graph will be something wider. It's kind of compressed, right? And to grab that one, it's not like slope that 1 up over 2. It's not that way. You have to multiply still the 135 by 1/2. This, which 1/2 here times 1/2 there times 1/2 there, which will be 1/2 here. This will be 3 halves. This will be 5 halves, or zero point 0.5, 1.5, 2.5. Okay, it's the same idea. Okay, so here I'm gonna go to the vertex. I'm gonna delete it so you can. I'm gonna erase this portion so you can see it. So again, I'm gonna graph the y equals 1/2 x squared. I'm gonna go to origin, go up by half over, go up by 1.5, half 1.5 over, go up by 2.5, 2.5, and then reflection, reflection, reflection. I will connect them. If you compare this to the parent function, which the parent function is y equals x squared, 0, 0, 1 up, 1 over, up 3 over, reflection, you can tell that the black graph is kind of wider, it's kind of compressed because 1/2 is smaller than 1, which is the value of a in our parent function. So to make the story short here, guys, is that the value of a tells us how skinny or wide or compress or stretch our parabola. Okay? All right, let's move on here now. So just by looking at this, describe how each function compares to the parent function. Number one, f of x equal to x squared plus 9. We know here the value of a is still 1, so it opens upward. Let's write everything we know. And there's no horizontal shifting here. There's a vertical shifting because of the plus 9, so this will shift up by 9 units, right? There you go. Number two, f of x equal to x squared minus 2. It's still going to open upward. So we know if it opens upward, that point there is the minimum value. Um, let's also find the, okay, this will shift down by 2 units because of the minus 2 here. Let's also find the vertex here. What's the vertex in number 1? The vertex there is 0, comma 9. And the isosymmetry there is x equal to 0 because of the value of the 0 on the x coordinate. The vertex here is 0, comma negative 2, wherein the isosymmetry is x equal to 0 also. Okay. Moving on, number 3. This one here, I see the plus 5 inside. If you go back to the rule, that's your h. So the vertex here is negative 5, comma 0. This is negative, so we know it opens downward, right? It opens downward. So therefore, that's a maximum value. The isosymmetry here is x equal to negative 5. Okay. All right. Mm, x minus 4 is telling us that it's going to the right 4. So the vertex there is going to be 4, comma negative 1. So it will, okay, I forgot to write here. This will shift to the left 5. Here it will shift to the right by 4 units. And it will go down 1. Okay, and what else? It opens upward because the value of a there is positive 1. Okay, next here we have a 1/3 here that tells us that it's going to be is a positive, so it that is positive, so it opens upward. What else? 1/3. 1/3 is smaller than 1, so it's going to be wider. It will be a compression with a scale factor of 1/3, and the plus 2 tells us that the vertex is go to 0, 2, and the isosymmetry is x equals 0. Okay, I'll leave number 6 to you guys to do. Let's do number 7 here. Mason grabbed the parent function of a quadratic equation, so we know that the quadratic equation is y is equal to x squared. We know that. Then he reflected over the parabola over the x-axis. So it flips down, so it becomes y is equal to negative x squared now. But it translated in 7 units up. So we're going to put a plus 7 there. But 3 units to the right. So this will go to the right. So we know it will become y is equal to negative x to the right. So minus how many? 3 units squared plus 7. So that is our new equation. Okay. Again, you have to know the vertex form, how to find the vertex there, the isosymmetry, the movement of the horizontal, the vertical, and the compression and stretch. Okay, and when it goes downward. All right.